Hi, everybody. Welcome. Uh, this tutorial is going to be the second half of this week's lab assignment, and that's going to be making our first technical drawing. So I'm going to use the, excuse me, I'm going to use the component that I used in the last tutorial, or that I modeled in the last tutorial, as the component for this tutorial as well. So uh, up until this point in the quarter, we have been working strictly in the design workspace, which is where we basically move from two-dimensional sketch geometry to three-dimensional parts. We are going to now move into our second workspace, which is the design or the drawing workspace. So to do that, we're going to move up to the upper left-hand corner and click on the design tab. And this is where we can select our different workspaces. We're going to go down to drawing and we are going to select from design. We're going to be prompted to select these things. This box here is showing me that I have a canvas inside of this assembly, or inside of this file. As long as that canvas is not visible, it won't be brought over. So you can just, for our create drawing, we have some things that we need to select to get this set up correctly. We're going to select visible only. In this circumstance, if we have an entire assembly that consists of multiple components and we want to bring all of that in, we would say full assembly. The destination, we are going to create a new drawing. So drawing is going to be create new. Template, we're going to say from scratch for now. The standard is going to be ASME, which stands for the Association, or excuse me, the American Society of Mechanical Engineers. They define the drawing standard for technical drawings in the United States. The European standard or the world standard is ISO, International Standards Organization. Units, we're going to leave in millimeters, but our sheet size, we are going to change to 8.5 by 11. Sheet size A, 8.5 by 11. There are two variants of this. One is for sheet size A. One is our portrait orientation. One is our landscape orientation. We're going to go with the portrait orientation for this example, and I'm going to click OK. Give it a moment to think, and it will bring us into the drawing workspace. Here, unlike the design workspace, we're concerned primarily with communicating in a two-dimensional way all of the dimensional information one would need to manufacture this component. When we're presented here, you can see that I have a component or a side view of our original component kind of like tied to my cursor. This is the base view, or the view that we're going to base all of the other information off of. We can change this view's orientation in this menu on the left-hand side here. If we go to orientation, I'm going to select top. And once I do that and it updates, there we go. You can see that it's done that. I accidentally left-clicked here, but that's fine. Some other things that we want to keep in mind, we can change the scale. So we can say 1:1, 1:4. We can say 2:1, etc. I'm going to leave this at 1:2, the default scale. And we're going to make sure that in this case, the other thing that to keep in mind here is that we have a style option here, which is basically, are we looking at the wireframe model of the component, or are we looking at a shaded model of the component? And for this circumstance, I'm going to leave this selected as visible and hidden edges. I'm going to click OK. You can see that as soon as I did that, it drops it into our view here. And I have a weird little visual artifact. I don't know why. There we go. Okay. Not sure if you guys could see that. We're looking at our part now. And the first thing that we want to look at is, just like in the design workspace, we have some different sets of tools that we use for working with drawings. These tools over here are about creating different views of the object that we're creating a drawing of. So we have our base view, which is if we have multiple components that are going to be placed on a sheet. We can utilize the base view to bring in essentially another component to start working with. So if we do that, I can bring in another base view of the same component, click OK, and you can see here that just like in the drawing, or excuse me, in the design workspace, we have these two individual components, and that in this case are a copy of one another. I'm going to go ahead and delete this. But if you have multiple components that you want to show inside of a sketch, or excuse me, inside of a drawing, you can use multiple base views to do that. So a base view is analogous to a component in the design workspace. Then we have projected views. Projected views are views that are based off of or are projected from a base view. If we have, and you can see that the view that is projected changes based off of the orientation relative to our primary view or our base view. And I want to communicate when we're looking at a drawing, the idea here is we want to communicate kind of visually what this component looks like, but also what are the critical dimensions that you need to have a understanding of how to do this, or to how to model this or manufacture this component. So I'm going to select two views that we're going to place here. We're going to select a view here and a view here, and then we're going to hit the enter key. And you can see that we now have some, if we zoom in here, we can see that we have some hidden lines that show us some information about our component. We can also change the styles of these separate views independently from the base view. By default, they inherit the style of the base view. But if we come over here and just highlight one, left click, and then double click one more time, it'll bring up this drawing view menu, and we can change the style of our component, of this component view, in this to show different information. And so I'm going to select shaded and click close. And then from there, from here, I'm going to, on this view here, I'm going to create a visible edges only view for the time being, and click close. Now that we have these two views, we're going to start adding some dimensions. So the hotkey for the dimension tool in the drawing workspace is the same as the design workspace. Just hit the letter D. We can see that we have our dimension tool activated up here. And here, what the difference here is that we're not going to be able to drive the geometry like we can in the design workspace, where we can say this is 100 millimeters or this is 10 millimeters. What the dimension tool does is it's going to look at a line segment, and you can see that it's giving us a dimension. This is inferred from the model that we are dimensioning off of. And if I come down to the bottom here, let's say we wanted the overall height. Here we have the overall height dimension. The dimension tool works or functions in exactly the same way as the design tool, in terms of if I want to get the overall height of this component or the overall width of this component, I click on here, left click, come drag, left click. We have our dimension in that direction. Left click here. Left click here. We have that dimension. Now, when we are, there's some other information that we need to start adding here, right? So we can say that this needs to be, we can call out this diameter. We can also call out this radius, and we can call out this radius. These radiuses should essentially be the same. You can see though that like as we continue to add dimensions, that we could, as we like, for example, add this dimension here, and then we add our external dimension here, right? And then, you know, we need to add like how far is the offset of this edge from there. You can see that this is starting to get kind of clustered pretty quickly. So what we want to do, what we want to strive to do, is work in a way that kind of makes these drawings legible. So I'm going to Control Z a couple times here and remove some of these. And this is what the different views are for. We want to think about what view or orientation of the part is it easiest to communicate a specific dimension. And there can be a number of different strategies to do this. The one for, in this case, I think it makes perfect sense to call out this, the diameter of that component. And I think it makes perfect sense to call out the diameter of this component here, this outer edge. Now, we know from our modeling session that this outer edge radius should be the same across all 4 of these locations. Instead of doing this multiple times, instead of doing that, we can communicate the same thing by moving this. If we double click on a dimension, we can see that we have these less than and greater sign symbols, these 2 carets. This is the dimension that's derived from the part. That's how Fusion denotes what is coming from geometry and what is not related to geometry when it comes to these dimensions. If we type outside of the caret and we just say for X, hit enter, you can assume now that if we see this feature, that these are the same radius, right? Now, some other tools that we want to take a look at. We have the center mark tool, which can mark the center of a circle or a radius. And this can be useful for dimensioning or denoting the size or the distances between different types of features like circles or holes or through holes or pockets, countersinks, etc. So if we have a center mark here, we could, for example, dimension directly this center to center distance, like so. But in this case, I think it would be easier to call out the distance from the edge to locate this. And you can see that these are starting to stack on top of each other. you can move these left and right so that they are, so that they kind of like are legible and readable. That guy there. Now we could grab a center mark here and here. And we could call out the center to center distance. And since this is a square, because we have 100 by 100, we know that if this is 80, this vertical dimension also has to be 80. We need to call out these two radiuses. This radius here and this radius here. We can do that a couple different ways. One thing that we can look at doing would be to, we could just call out, and in this case, it could be perfectly fine to do so, these two radiuses, like so. And the convention typically is to model or dimension off of the outer edges of the components. The reason that we do that is if we're in a scenario where we are doing a subtractive manufacturing process, these are we have to account for the stock that we're going to be using. Something else to consider, though, what you call out as a dimension is somewhat dependent on what the part is intended to do, right? So if this is a component, and I don't know what this component is for, but let's say that this component is actually that these cutouts here, these like little pockets, are in fact locating locations, that there is a mating component that uses these locations to locate itself accurately. In that case, it would not be preferable to dimension off of this outer edge, because remember that this is a chamfer. So we would instead actually want to call out the critical dimension of the inner edge here, which is 4.19. Because this is that inner edge dimension is where the two parts would technically interface with each other. And if there needed to be dimensionality, or you needed to hit a specific tolerance on that radius, you would need to call that out here. So now we can look at some other things that we want to consider in our dimensioning, which is the edge location of this radius is a potential option. Don't think that would be terribly useful here, but what would be useful is finding a way to orient ourselves so that it is understood what this dimension is. Now we could dimension it here, but we have a lot of dimensions. Oh, let's zoomed out here. Where's my go to pan? There we go. So we'll click the fit button. If something happens like that, you get off screen and you don't know where your drawing is in the drawing space, you can just click fit, lower right hand corner, and it snaps you back. Snaps you back there. So from here, what we can do now is the where was I? Oh, that's right. We were dimensioning off this edge. So here I was just talking about dimensioning, finding this dimension, right? We could call out this dimension in this way, but it may not be this might not be the most preferable way to do this. This drawing view is already starting to get a little clustered. We have a lot of dimensions coming off of this. It can be a little bit difficult to read. Move that down here. There. Right. What we want to do is find a way to communicate that in a way that's it's clearly understood. Delete this one. So with that in mind, I'm actually going to create a view off to the left here. I'm going to create a projected view. Before I do that, I'm going to relocate some of our dimensions so that these are a little bit easier to read. And what we're going to do is we're going to grab our projected view. We're going to select this as our base view. We're going to click OK. Now when we're looking at this component, we can dimension in this direction. In a way that is easily understood, less clustered over here, not as many intersecting lines. It could also be a good idea to move this dimension like here. That's not any better. I think we'll leave that for there for right now. There's one other thing that I would like to show you, which is what we call a section view. A section view is we create a section view by activating the tool, selecting our component, and then this cursor, we're going to basically define how we are going to slice a component. Click OK. And this section view now is essentially us bisecting this component and turning it on its side. And so this radius here corresponds to this diameter, like so. If we come in and dimension off of here, we get our 11.25. If we dimension here, we get our 10 millimeters, which is this dimension right here. And we can also call out our chamfer size, etc. You can see that we have this label that appeared down here. This is the This denotes the section view. This is the label for the section view. So if we move that down, you can see that that label moves with our component. Like so. So what happened here is that I grabbed this dimension and I took it away from its 2 reference points. That's what this little icon means. If we right click, if we left click, and this menu pops up and we can either delete it or we can reassociate. If we reassociate it, we just reselect the points that we're going to snap to. So we're going to grab our center point. If I have a section view here, that's kind of, so this goes here. There we go. And then the other one goes here. Huh. I'm not sure why that's not working correctly, but we'll just delete that dimension, reactivate our dimension tool, and grab those dimensions again. Once again, fit. There we go. So here, this is, we are essentially at the point where we've kind of like defined what the geometry is that describes this component. The only other thing that is not described yet is actually one of these corner radiuses. So I would probably come down here and do that. Come out here, do by 4. That piece of information is redundant. There we go. And this would be, essentially a first run at or a first draft of a technical drawing. There are some refinements that can be gone into this. Some different views can be selected, but for the sake of not making this tutorial an hour long, and this is really just an introductory tutorial for the tools that are involved in making technical drawings, we can have, I think this is probably a good place to stop. What we want to do, though, the parts that you guys are working on this week are a little bit simpler to dimension here. And the things to keep in mind as we're going about this is, how do we communicate the geometric information that's necessary to manufacture the part? So what are going to be the important pieces of information to know? What are going to be the critical dimensions? Those are going to be driven by the functionality of the part and our understanding of how the part is intended to be used. So those types of things. So this week we are doing 2 things for our assignment. We are we're modeling a part from an image in Fusion 360, and then after we've modeled that part, we're going to create our first technical drawing of that component. With that being said, if you guys have questions, please reach out to us. Reach out to us on Discord, Canvas, come into the lab. Happy to offer advice on how to lay out technical drawings in more detail. If you guys, if some of how some of these tools are unclear, or how they work is unclear, happy to go over those again in person. With that being said, we're going to cut it off here. We'll see you guys next week.